Hi guys, how are you?
Okay.
Yeah, guys, everything must be cool now. Give me. Yeah, I hope you're well. You can say hi on the chat. I'm here to listen to you. Thank you for joining. You can say hi on the chat, guys. You can say hi on the chat. We are starting in a few. You're just waiting for more people to join. You can invite your friends. You can invite your friends so that we do this. Let's do this. We can make it. We can make it, guys. Today is going to be awesome. Today is going to be a good day. Yeah, we are working on designing an LLM, large language model, and we designing an LLM, and for sure it's going to work. It must work. It must work, if it likes it or not. Yeah, uh, yeah, we can go on. We can start. I want to make sure that I have nice preview. And there we go. I hope you are doing well. I hope everyone is well. Yeah, welcome, guys. In case you are new here, this is not our first day. This is not our first day doing this. We have been doing it for some time, so this is not our first time. So I'll just go ahead and start building. We are going to build until we get tired, maybe roughly 1 hour or something of the sort. Okay, let me just do it. There we go. Yeah, we are good. We are good now. We are good. In case you want to get the repo is in the description. It's in the video description. So you can check the repository of whatever we have been working on. Just click the description and then you're going to get the repository of the final build that you expect us to build. So we have done this in 3 phases. Today is day 3 of building the LLM. Today is day 3. So day 1 was according to the videos. You can just go to the channel, check on live. Then day 1 was day 11. That was day 11, day 12, and day 13 of building this LLM from scratch. So those are the days. So we are in session 3. So most of the things we are going to explain how they work. So whatever we have been doing, we are building an LLM where you can just something like GPT, where you can just prompt and then it works out. Where you can prompt anything and then it works out. It gives you a response. We are not just going to use any API key. We are doing ours from scratch with 10 million parameters of data, or with 10 million parameters. You are going to do 6 blocks. We have already explained what is 6 blocks. When you go to the previous videos, you are going to get the kind of blocks that we're talking about. Then yeah, we are doing in phases, and I think today we are going to be doing the training. We have already covered all these other phases: setting up environments, installing all the dependencies, detecting your devices, all this, getting the training data. Where do you download the data for training this AI? It's all about data intensive. Where do you get the API or the data from? Data loading we did. So you can check out the previous videos and see how we build it. Otherwise, you can check the link in the description. The link in the description, then you can take the full build. Okay, so today we are going to be doing the training configuration. The training configuration. So nothing crazy, nothing crazy. We have already done most of the parts. We have designed the models. We have designed the data, downloaded the data and everything. This is the code for doing all that stuff. Then the virtual environments, everything that you need, the configurations, everything. So in case you go to that link in the description, you're going to get every single description of whatever we are working on. So just go to my GitHub, then you are going to get the link for that. I think all the links are well defined if I check. Let me just confirm. Yeah, you can follow the descriptions or the README, then you can set up everything that you need. And then you have your 10 million parameters of data AI that you can ask, that you can train and make it better. So let's just continue from where we left last time. This time we are doing the training. This time we are doing the training here. So remember, whatever packages that we installed, we have NumPy, we have TikToken, TQDM, we have request, then we have PyTorch and NumPy. So these are the basically these are anything, all the packages that we need, so we can go on and work on these remaining parts. So I might be required to copy some things here and just explain how this works. So this one will be very easy. It won't be hard. It will be extremely easy for us. So we need to import, let me just check this. We need to import the math library. We need to import the time, and also we need to import torch. I think torch. So these are the libraries that we need for us to be able to train our AI. So this file that we are working on is the file that is going to enable us now to write the training file. So once whenever we run this train.py, then it's going to train our AI. And all the logic we have already defined in all these other files, like the configuration, the models, the attention, the GPT layer, and all this. You can check out the previous videos, then we can know how we defined the model. So from config, I think I need to import get device, if I'm not wrong. Get device. Then also I need to import from model.gpt. I'm going to import simple GPT. So as you can see here, for example, in this part here, in this model.gpt, I'm not just importing it from the blues. Remember this model that we created here. See, model we created right here with all these functions. So basically in this code, I'm just telling it from here, model.gpt file, import this function that is gpt function. Yeah, it's nothing crazy, just like that. So from data.loader, um, import import get batch. Is it batch here? Now you can import data in batches. So basically, whenever we are training this model, whenever we run this, instead of getting the whole data in one chunk, now we can import in terms of batches. So we can import this data for training in batches. So in batches, that means we won't import, let's say we have 1,000 columns of data. We don't have to import all the 1,000. We can import in 10 batches, each 100, 100, 100. So that's what we call batches in our case. So let me just copy this file here. This is a lot to write. Then we explain. So over here. So basically here, whenever I'm creating the training function, I need to design several things when it comes to the training. So the first thing is the model architecture. The model architecture. So there's something that we call embedding. So the number of embeddings, we are going to use the standard of 192. So basically this is an embedding dimensions. Must be the number of heads here. So the number of heads here, I think we defined here in things like the attention, the head attention, the multi-head attention. We already defined all these terms right in those different files. So we can also take the number of heads we assign to 4. So basically we have 4 attention heads. So in case you want to refer from this attention.py, we defined these attention blocks right here. The attention and the transformer blocks right here. So in case you want to know more, the previous videos already defined all these key terms. The number of layers, these we are going to have 4 blocks of transformer blocks, 4 layers of transformer blocks in that case. Then block size of 128, the context length is 128. Then of course the dropout layer is going to be 0.1. The dropout is the error, the percentage that we have given it to have an error. In simple terms, in case we don't want our model to overfit or our model in the process of training to be 100% accurate, in which it can't be 100% accurate, so we are giving it some mistake, some space for to do some mistakes. That's why we have the dropout here. So in the process of training, so in the actual process of training, we can divide our data set into that two batch size of that two. So the maximum number of steps it can take is 5,000, so that it does not overtrain or it does not exceed or overconsume our CPU. Remember that in the process of training, we are expecting our machine to use a lot of CPU, a lot of hardware space, or a lot of that heavy task. We don't want to overheat our machine or to basically overwork our machines. So that's why we also limiting the number of maximum steps. Also the number of intervals that we are going to do, everything just as simple as that. And of course, we calculate something we call learning rate schedule. So we define some learning rate schedule over here. Then also we define the grant and clipping, basically to provide exploding of the gradients. So the moment that we write the entire code of this file, then we are going to see all these in actions. All these in actions. So basically that's how we are creating the training, just like that. Now we want to write a function that basically we are going to calculate the learning rate schedule. So we are going to define the learning rate schedule. This is we are basically saying learn at this time, then you schedule the next learning, just like that, to avoid all these kind of problems that might occur in the process of training our model. So over here, we are going to define a function in which you are going to call it get learning rate, and then we define some steps. Then we define steps in which our step is an integer, which can be converted into a float. In that case, float. Then we can define this function. Then in this function, we can define something that we can call it a variable called maximum learning rate. LL means learning rate. Maximum learning rate, in which you can define to config, in which, remember this configuration here? These configurations are the ones that we want to assign here. So this one is not a new word. We are just assigning these configurations. Yeah, we're just assigning these configurations here. So it's nothing crazy. Configurations, then over here, we can say the learning rate. We can assign this to learning rate. In case you are wondering where I'm getting these keywords are already here, the learning rate here. So there's nothing crazy that I'm writing. We have already defined here. So whenever you get the maximum learning rate, we can also get the minimum learning rate. If we can assign maximum learning rate, we can also assign minimum learning rate. So in the minimum learning rate, we can assign to minimum learning rate, in which is this one here. So basically the one we are using here. It's the minimum learning rate. So we need warm-up steps. We need some warm-up steps, in which, same case, we are going to use the configuration, the config, then we assign the warm-up steps. We assign these warm-up steps. So basically, we are just creating the learning rate. We are going to add more features. One feature that we need to add is the maximum learning rate. That should be always included. The maximum learning rate. We don't want our model to overfit. Maximum learning rate, which we just defined here. No, not maximum learning rate. Remember, it's maximum steps, sorry. Maximum steps, in which it should be maximum steps. Number of steps. So this number of steps here, maximum number of steps, we have already defined right here. So nothing crazy, we are just importing all these here. So once we define this, the next thing that we need to do is we calculate the number of steps. If the number of steps is less than the warm-up steps, then we need to do something. So we need to we can return the maximum learning rate. You multiply by number of steps, step plus 1. Then I'm going to explain what it's doing. Then you divide by warm-up steps. So basically here we want to know the step. So if the step, remember the steps here, we have defined here the maximum number of steps. But before we get the maximum number of steps, generally we need to know the current step. So if the current step is less than number of warm-up steps, is warm-up steps here. So if the current step is less than number of warm-up steps, so you return the maximum learning rate, multiply by, take that single step, and then you just plus 1. So that we can get to the warm-up steps. Before you reach the warm-up steps, so what do you do basically as a human being? You increase the step. So basically we add a step. Then you check again that loop. Has it reached the number of warm-up steps? If it's still less, then you can do that. Then you divide by the warm-up steps. So basically that we are calculating the linear warm-up. So in case there's something that you need to see or you need it explained, you can say, you can text on the chat. Anyway, you guys can also text on the chat. You can say something on the chat. Say something on the chat. So after we are done, we can calculate something that is called the cosine delay. The cosine decay, not delay. The cosine decay, we can say decay. Let me, and then I will explain the decay ratio, in which is step, in which you are going to take the step minus warm-up steps, divided by the maximum number of max steps minus warm-up steps. Then the warm-up steps increment by 1. I'm going to explain this code, what it's doing. Then you calculate the coefficient. So the coefficient is equal. That's where now the machine learning and AI and mathematics comes into play, in case you are new. In case you have ever heard about machine learning AI, for you to be good in it, you need to understand mathematics. Now that's where the mathematics comes into play. The mathematics, math.cosine. Is it cosine? You remember the Sokoto kind of thing, the math.pi. I'll explain what's going on. Calculated by decay ratio. Then we can return, let me do this and then explain. We can return minimum learning rate, add the coefficient, then you multiply by the maximum learning rate, then minimum learning rate. So let me explain what it's doing here. So this is we are calculating, or we are trying to assign learning rate of our AI. So this learning rate, we want to be so careful whenever we are doing it. So remember, we defined the maximum number of steps, maximum learning rate, warm-up steps, all those kind of stuff. So here, we basically want to make sure that it repeats itself, it calculates efficiently. calculating the cosines, the pi and everything, because it's a loop. Basically, it's a loop that is going to do all this kind of stuff. So basically, that's whatever you are trying to do here. The decay ratio here, you are just taking the step minus the warm-up steps. So let's say we have warm-up steps, we said it's 200. Now let's do the mathematics here. So if the warm-up steps is 200, and for example, I've taken like 50 steps. So the step then minus the warm-up steps divided by maximum number of steps, maximum steps minus the warm-up steps. Basically, that's whatever we are trying to do so that we can get the decay ratio. Then we can calculate the coefficient here, in which we are going to take 0.5 multiplied by this one, that was the gradient clip, in which we define the math dot cosine. Then we just take the pi, then we multiply by the decay ratio, in which the decay ratio we had already calculated right here. Then after everything matches, now we can define, or we can basically return this so that we can close this function for calculating the learning rate. For calculating the learning rate. So we have already calculated the learning rate. So the next thing that we need to do is to calculate the loss estimation. The loss estimation. So whatever we are trying to do, remember we said whenever you are training AI, it might lose or it might be inefficient. So we want to see how much in the process of training we are losing, or in the process of training we are losing so much. How much we are likely to use or to lose. Estimate loss. So basically here we want to calculate the estimated loss. So to calculate the estimated loss, we need model that we use the simple GPT that we just imported. Training data, this should be train, let's go data equals to torch dot tensor, tensor. Then we can assign this the value data, valuation data. Then we can assign this to same torch.tensor. Torch.tensor. The last thing that we need to get is device, in which it's not necessary, but I can get it. Device, we can assign it to a string. Then over here, because it's a single function, we can do it like this. We can assign it to a dictionary, in which our dictionary is going to have a string and float. It's going to have string and float. Then we can make this now a function. So basically it looks like this, Maybe I can format this. Let me try to format this document to make sense. Yeah, it looks like this in a simple format. It just basically looks like this. Instead of writing it in a one-liner, it looks like this. Very simple. So we can take the model dot eval model.eval, oops, then we can take the results. We're basically calculating the loss. So there's nothing crazy that we are doing here. We just want to make sure that our model doesn't overfit or doesn't we don't get wrong results without calculating the kind of loss that we are going to get split. So for split in, I'm going to explain whatever we are trying to do here. In the training data, then in the evaluation data, so we are going to calculate losses, in which is going to be a variable losses, which we are going to assign to yeah, it should look like this. We pass the model, in which the model we already defined. Then over here, let me check, let me confirm. So instead, let me just copy this to make it easy, for this function here. So this one closes here, then that one here closes the loss, then we get the results here. Okay, let me just copy from here. Yeah, that should work. Let me check. Well aligned to avoid indentation errors in Python. So over here, let me explain. So for split in the training data set and the evaluation data set, then we calculate in the loss. Remember the model here that we defined? The model here we are going to calculate by for t in the get batch. Remember this get batch here? It should get a batch. Remember we defined a batch size here. This one here, get batch from the data loader here. So we already defined it. So we are going to take that split data, the training data, then the evaluation data. Then we are going to assign it to the block size, the configuration that is batch size, and the device that we want to do. So basically, in layman's terms, we want to calculate the estimated loss. Let's say we wanted to get 100% accuracy. Remember, we defined tools in how we are going to train our AI. It has a batch size of 32. Maximum number of steps that it should take of 5,000. Then we defined the learning rate, the minimum learning rate, and the warm-up steps. Have that in mind. So basically whatever we are trying to do is we want it to be accurate. Make sure that you use the block size. The moment that you are calculating the loss, to use the block size, use the batch size to calculate how much loss we are going to get from the training data set or in the process of training. So where do we get this? In case you are wondering what keyword are we using here, remember we defined all these keywords in all these different files here. In all these different files here, you can check the previous videos, then you can check all these kind of terms that we defined right here in all these different parts. So the chart, the configuration here, configuration as well. Then we are here in the training process. So these terms we already defined some time back in the previous videos. So someone is asking, what are we doing? So what we are doing, we are trying to create an LLM from scratch. You see how you can go to your GPT, then you can text it, and then it gives you output. Now, as we are learning how to do that step by step without using any API key, with only using our raw data, for example, your own data, then you can ask questions from that data and how AI learns. So basically, that's what we are trying to do, creating it from scratch. Now, the accuracy of these AI that we are going to train, all these models that we are going to train, the accuracy depends with how much time we train and how much data and how accurate is the information or in that data. So that's what defines how accurate, how efficient is our model, or is how efficient is our system. So yeah, with that said, let's see what next. Let's see what next right here. So the next thing that we need to create is called the training loop. The training loop here. The training loop. So what is training loop? Training loop is just in layman's terms like let's say you are running a race, you need to go like 5 times around that field. So basically you need to do one loop, second loop, third loop, fourth loop, something like that. You can define it something like that. But now when it comes to our system, it might be different now. So let's see how now we can do that, how we can do that, the training loop. So we define a function that we are going to call it the main training loop. The main training loop, in which is going to use the simple GPT. Simple GPT. Then we are going to do all these kind of things. The first thing that we need to define, or remember that we need to take care of our device, the device that we are using. So we are going to use the get function of the get device. We are going to get device. So right here you can print out the device. You can decide to print out, oops, print device training on this device. Which device is this? Training on device, whatever device that we are training on right here. Whatever device that we are using. No. It like this, whatever device that we are trying to train on, just a single one. Single, where's the single? The single one, it should be the single one. So we are training on which device? We are training on which kind of device? So we can get the device that we are training. Nothing crazy. It will just print out your name of your machine and the capacity and all the CPU of your machine. So this one is unnecessary for now. It will just print out the system that you are training your AI on. Nothing crazy right there. So back then, in the previous video, we downloaded data and we tokenized data. We tokenized, where did we tokenize the data? Data preparation here. So we prepared and tokenized our data. So basically, we want to load tokenized data into our training. So we can define training data in which we are loading it from touch dot. We are going to load. We are going to load the tokenized data. So tokenized data is, we are getting it from data.train.pt. Train.pt. So in case you are wondering why don't we have the train.pt, so basically it should look like this. So we are fetching this data from data, this folder for data, this data for folder for data, then we load the train.pt file, train.pt file. But currently we do not have this training data, this tokenized data. So what do we need to do for us to get this file? Very simple. For us to get that, we need to, let me see, existing, skipping download. We have already downloaded the data. This loading. We need to run this file for to tokenize the data. We need to run this file for preparation so that we tokenize the data. So we are going to run later. So basically running this is just like, I don't know if I have the runner, or you can just python.py, python, then you run this file here, prepare data. But for now, let's not run. We can just prepare and then we run it later. We can prepare and learn it later. Wait only it's true. So wait only is true. So the valuation data is equal to touch dot load, same concept, in which is going to data slash val.pt, in which still going to use the wait only, which is going to evaluate to true. So these two data sets, all these tokenized data, whenever we run this file, prepare.py, then it's going to create those files for us automatically with the tokenized data. So we don't need to worry about anything. So remember the tokenized data, we define something that we are going to, we call it vocabulary size. The vocabulary size is going to, of course, is going to be an integer, then maximum integer. So we are going to check the training data, this one here. So so that we calculate the vocabulary size. Dot max, that we get the max, which then of course we have the valuation data, in which we're also going to do dot max, in which we are going to do the dot max. Then we are going to print out the item, get every single item in there, then I think +1. We get the +1 here. We're just converting all this. We are just looping through these vocabulary sizes right here. So in case you want to print out the vocabulary size, you can print out here, like print out the vocabulary size, in which it's unnecessary. So the next thing that we need to do is, now in the process, now we want to build the actual model. Just write that small function that build the actual model. Now everything here we have been doing is just organizing, taking the data, joining the data together, and now we want to build a model. So we can define a model, and the model is going to use the simple GPT library that we just wrote for ourselves, or function. Then the model is going to have the vocabulary size, in which the vocabulary size is going to use the vocab size, the number of embeddings is going to use config, this configuration that we just wrote. Then here is going to use the number of embeddings. So this is a lot of work. Let me just copy this file here. So basically it looks like this. The vocabulary size, it's equals to the vocabulary size, config, the number of heads, the layers, the block size, the dropout layer, everything just like this. Then it converts to a device. It saves that model into our device. So it basically saves that model to our device. Now, after training this model, after now creating the model itself, we need to create an optimizer. So our model needs to be optimize the model. So we need to optimize the model. So we can create optimizer in which you are going to use the torch. Why do I keep mistaking the spelling of optimizer? Adam optimizer, the Adam optimizer, in which you are going to pass the model dot, we check parameters, the number of parameters that we defined parameters. The parameters, we pass the parameters right there. Then of course we define the learning rate, in which, you remember, the learning rate is equals to config. We get the learning rate from the configuration. Then of course we pass the learning rate right there. Then we finish this by calculating the weight decay, in which you are going to pass 0.1. That is the error rate. Then we are done. Imagine we are done with optimizing the model. And that's it. Anything else that is remaining? Let me check. The training, we loaded the data. We got the vocabulary size. We build our model. Then we optimized with the Adam optimizer. I don't think there's anything else left unless we do, yeah, one last thing. So we need to start the training process, in which is equals to time dot time. We're going to define why time dot time. Train losses, in which is going to be an empty array. The valuation losses, in which the same is going to be an empty array, an empty list or array. So that's what we need for now. In the process of training. Think we are done. Let me check. So here in the training, in the process of training, that's where we have a lot of work now, creating the training. So let me copy the rest, then you try to explain. So I have to be accurate up to here. Let me just copy up to here, then explain what's happening. So the next thing that we need to do, remember we defined the training process and the training procedure. Remember when we said we need to, in the process of training, we said we need to calculate the number of steps, the number of maximum steps this model can train. Okay, the number of steps that this can train. Now we are expanding that logic further to, so for any step in the number of maximum steps, for any step in the number of maximum steps here. So what we want to do is, first of all, evaluate. Evaluate what? The learning rate. So if the step, so if we have any step in that interval is equal to 0, so if the deviation becomes to 0, the modular, the remainder is 0, this basically means it's a modular. It's a modular. You are getting the remainder. So let's say if we have no remaining steps, basically, if we have no remaining steps, so the steps is the steps in the process of training. Now let's say we have taken first step, second step, and then when we check the number of remaining steps is equal to 0 here, then now that's where we need to produce the output. And the output, here we were calculating the loss. Out of the number of steps that were taken, do we have any loss? Do we need any loss? Now that's where we calculate here the estimated loss. So in the calculating the estimated loss, we pass the model, the training data, the evaluation data, then the device, so that we know what problem we have. So in case you're wondering where we getting the training and the evaluation data from, now we said our model can evaluate to 100%. Now we need to divide that 100 data into two data sets, the training and the testing or the evaluation data set. So first we need the data set that we need to train, then the one that we are evaluating against. So basically it's very simple. Let's say you have been given an exam. The exam equals to 100%. So remember that we have the exam with the answer sheets that will evaluate to 100%. Now your score in the process of doing your exam, you get 90%. Why are we saying you got 90%? Because we already have a marking scheme that determines your score rate. That's where we are taking the training, the data set. Basically the same logic that happens. Why are we getting 100%, 90%, whatever percentage that we have? So that's how this is being calculated. So basically that's how it's being calculated. So what else? What else? Let me see. So the elapsed time, we calculate the time minus the start time. Time dot time minus the start time. So the elapsed time is basically like how long have you taken to train? Take whenever time it is started training, whenever time we started training our AI, then time when it stops. That's when we calculate the elapsed time, how many minutes it took to train. Basically, this one is just printing out this outputs the elapsed time, whatever time we have. So here we have the loss right here. Training loss dot append the training here. So basically, this one is not a big thing. We are just taking the loss that we calculated. Yes, we said out of this training we did not get 100%. We got 90%. So the loss is the 10% that is remaining. So take the loss dot append in the training process. The valuation loss dot append what in the valuation, so that we get the 100% now minus the loss. So we get the model accuracy. So this one thing that we need to do, the final thing, this is just basic knowledge that calculates evaluation only on final step. Now, this basically does this. You're only doing evaluation whenever you have taken the final step. In layman's term, logic is you are only evaluating your exam the time you do the last question. We can't say you have scored 80%, yet you have only done 3 questions out of 10. So we need to wait for you to do the 10 questions so that we can evaluate. So basically, that's what we do here. The moment that you get the final question, then stop and now start the evaluation. Basically, like that. No more logic that we are just doing here. So here we are just calculating the forward and back, getting the batch sizes. Remember that we said we are defining, or we are dividing our data into different batches. Just a moment. So remember that when we said we are going to divide our data into different batch sizes. So that's whatever we are trying to do here. Get the training data, the block size, and everything right here. Then the loss, it's a model XY. So basically here we are trying to create a graph. We are just trying to draw a normal graph to calculate the loss or to see the training trend where we got lost, where our model is not doing right. That's whatever we are trying to do here for only for our visuals, just to calculate how accurate whatever we are trying to do. The trend graphs, that's whatever we are trying to calculate right here. So the optimizer dot zero grad, we start from 0 graduate graduation gradient, sorry. Then we set to none. It's equals to start everything from 0. Then calculate backwards. Calculate backwards. So updating the learning rate, updating the learning rate. So remember, the learning rate is being determined by so many things: the number of steps, the batch sizes, and so many things. So to calculate the learning rate, we need to take the parameter groups, the param groups, in optimizer dot param groups. Then we get the learning rate, also the number of steps, the learning rate, and then we call it like that. So let's do the last bit of this development, the last bit of this part. The last bit is not hard, it's very easy. The last bit is very easy. The last bit is very easy. So it's not a must, but it's not necessary. It's not necessary. It's not necessary. Yeah, it's necessary. So remember, So what do we do whenever we run our code? Then it trains, then we have the trained model. So what do we do? So we need to update our file that contains the training model. So we just import OS, then we make directories. Make directories inside the model. See here, inside the model here. So we need to make a directory. We need to make a directory. So check the path model.simplegpt. So do you have simple GPT right here? No, not yet. So that means if that one does not exist, if this file does not exist, then we create that file. So this one is going to be created in this step. So basically we are creating this file that is called simple GPT. So when is it being created, or why are we creating this file? Now let's say we have trained our model, our code is running, everything, and we have the model that is already trained. So we package it into PT file, type file. Then we just create that file for trained the trained model. So basically that's what it does. Basically that's what it does. Then the final thing is now basically drawing the graphs. Basically drawing the graphs which are not necessary. So basically this is just presentation. Optimal loss plot. So basically this one is just creating the graphs, that file, to see how visualizing the output, visualizing everything that we just did. So what are we trying to do? We are trying to create a file that has graphs. So no more thing. Let's say now you have been taught, now explain whatever we did here. How our model learned from step 1, step 3, step 5, how many number of times we trained our model, everything. So basically this one is just using matplotlib to plot a simple graph. Now this one will just print out a simple graph that we have. So so that's it for this file, that is the training. So what are we missing? According to these steps, we are missing several things. We are missing these files. Where are they? We are missing the train.pt, the val.pt file. Then we are also missing which file? The simple gpt.pt file. All these are not necessary for now until we run the next steps. So the next steps for us to run, it's very simple. It's very simple for us to run. You can check out how to run these files in our readme file. So let me check. When you go to the repository or to the repo that is in the description, it's guiding you how to run these files. How to run these files. Very simple. Installation, tokenizing, all the libraries that you need, whatever part that you need, understanding each file, downloading each file, executing each file. We have here the model, the self-attention, everything. So for you to chat with the file, you need chat.py or this file, So we have the process in which you need to get the data. So troubleshooting, for you to troubleshoot, if in case you run and then you see things like file not found, you need to run python download.py. So if we run this file, python download.py, it's going to make sure that we have our data downloaded. Our data downloaded. So, for example, let's try to run. Let's try to run this file. I want to minimize this. I want to run some files here. Here, as cd data. Then I can run python download.py. So if I run python download.py, as you can see, there we go. There we go. So it has created the data. You see this input.txt. It has downloaded the data that we need to train our model with. So it's basically downloading this data from this URL. Basically downloading the data from this URL. So if you go through this documentation, then it's going to give you all the files that you need. For example, the file that we were talking about, the train.pt, is basically simple. Just go here, follow the documentation, run prepare.py. So where is our prepare.py? Our prepare is right here. So I can run python prepare.py. Then it's going to prepare, then tokenize our data and everything. So it's going to take a while, few seconds. Then it's going to give us the train.pt, file. So it's going to take a while because it's doing a lot of process. So if you check the prepare.py, it's going to do the building the vocabulary, doing the encoding, decoding, preparing the data, all this process. It's trying to do all this process. That's why it will take some time to do that. You don't know how much time, but the moment we execute, then it's going to work. There we go. Vocabulary size 65 encoded data. And you can see it has provided train.pt, val.pt, the file that we were talking about, the file that we said we do not have. Ooh. As you can see, this data is unreadable, but it's readable for AI. It's readable for our AI. Disable invisible highlights. So this one is unreadable, but this is a tokenized data. This is what we call tokenized data. So this is what we call tokenized data in this PT. Yeah, so that's how you run all these steps. You can check out. Now we can run this. Actually, do we need let me try. Let me try to train this file. Now it's the process of training. Where is our training? Let me check. Our training file is right here, so we don't need this. We need to go one step. Python. Let me see how we are going to achieve train.py. If you are going to train our model, I hope it works. There we go. There we go. There are so many problems. Train. Line 182. Line 182. So we have that. We have a read basic file. Open in file. Open like whatever. What file is this? Serialization. Open name mode. Yeah, I know all these problems. I know all these problems. We can't find the data train.pt. It can't find this data, but we have. Okay, it can't find this data. I know. It's saying it can't find the data train.pt. So that's not a big deal. It's a small problem. So let me find this train.pt. So yeah, it should be inside data. So that's not a big deal. What other error do we have? The train, line 182. What do we have in line 182? Okay, let's try again and see if that error arises. Few errors now. So it's saying must recall file train. Oh, train in this line 84. Line 84, we have a problem here. Line 84. This one is full stop dots. That might be causing other problems. Oops. Okay. That gave birth to other problems. Now it's the time to debug. But this one saved. I don't know why it says still complaining. Line 84. Line 84 we fixed. We fixed this one here, Max. So that one should never complain. So that's why it's simple GPT. But we have this simple GPT. We have simple GPT. Let me search across simple GPT. But we have this function simple GPT. It might not have been exported well. Okay. That's not a big deal. That's not a big deal. Now that's where the programming comes to play. Let me go back here. Let me proofread this file again. To device. Simple GPT to device. That must be a typo. I think all these are typo problems. To device. Model.simplegpt. Let me check. Build the model. We have model.simplegpt .2 device. I might be required to copy some things here, and if it works, let me check. This one here, the model here, everything seems correct, but I might have missed something, so that's not a problem. Okay, let me read this error. Train. Okay. Minimal errors here, right here. Train files, simple GPT. vocabulary size is equals to vocabulary size. That's where the problem is. The vocabulary size is equals to the vocabulary size. And it's only one this line. Dropout is equals to config.dropout. Maybe we don't have this dropout in the config. We have config and then we have dropout. So that one should not be complaining. Okay. Let me just copy the entire file and see. Just going to test if it works. And then if it works, then must be indentation errors. No, same problem, same problem. So this one should be data/data/data. Nothing special, same problem. Okay, let me just undo. So okay, let me run this and fix this with the AI. Let me oops. So I'm going to fix these with AI. Cloud code here. Where is the error? In the add chain.py. Let me check. Let me check. Let me just debug quickly with AI. It is saying that n heads is equal, it should be number of heads. Okay. Optimizer is equals to Adam optimizer. Okay, let me see. It's replacing the same thing with the same thing. Two fixes. Number of heads changed to the num heads. Oh, I get it. I get it. Up down setting. Torch dot optim dot Adam w. Underscore should be a dot. Oh, okay. I used underscore instead of dot. I see. Then this one should work now. It should train our model. What? Oh, it might still be caching. So let me check whatever it fixed. It might be caching. This is a cache problem. Let me see. Yeah, it replaced this number of heads. Dropout, no problem. It's okay. Let me run it again. Let me see. It must be spelling problems. Okay. Dropout. Let me fix this. Dropout. 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 Attention. Self.dropout. Let me check. Cross check if this is the same. But this one is defined as dropout. This one in GPT. Let me see if we have dropout. Yeah, everything is defined as dropout. So this one should be correct. So the dropout should be correct. And again, I will have to pass more errors right there. This one should pass all the tests. Which file is it editing? Two fixes applied. The initial weights, forward initial weight. I might be missing some typo. It's a lot of typo. This seems to have worked. Do you see? Oh, oops. You almost worked, man. You almost worked. So we have more problems on our side. So it's just inspecting everything step by step. I'm using Cloud Code. I'm using Cloud Code to debug these. Okay, I hope it won't cache. So whenever you see it taking long, there are chances that it's executing, it's doing well. You expect a positive feedback until it finds a step and then it breaks. So this might have worked. This might have worked. Let's see. I just wish it works. There we go. It's training. It's training. Actually, we are training. There you go. It worked. It fixed. Basically, my AI just fixed some typo problems. Typo, missing commas, missing semicolons. Actually, you can see it's now training. We are finally training our model. So the first time it trained with all this, I should have added headers right here. I will add headers so that we know whatever we are working on. So it should run everything and then terminate itself. So let me see if it created any file. Oh, there you go. It created the vocabulary JSON. As you can see, it's still creating more files right here. Still assigning. So you might never understand some of these files. So still working, still training. See, it created the input.txt. What else did it create? Let me see in the model. Model, nothing created. So it's still working, still running. So you can do it several times. You can do it several times. You can just wait for it to run several times. So once it's done training, then you can train it, you can retrain as many times as possible for it to for it to be accurate. So the moment that you feel it's accurate enough for public use or for personal use or for consumption, basically for use, then you can go further with the next steps. So that's it for whatever we have done. So what is remaining? So the only remaining part is creating an interface for one now to communicate with it. Interface, for example, I can just go to cloud, a simple interface, and then speak to my cloud. Okay, so that's what is remaining that we are going to do in the next live session. So in the next live session, we are going to keep training, basically train, leave for an hour, come train again, leave it training, leave my machine training, come after some time, everything just like that. So the moment you are done with training, now we can create the chat.py. So basically the chat.py is going to be here, the chat.py. This file here that we prepared, chat.py, that's the only thing that is remaining. We are going to work on it in the next live session. So I'm going to leave mind training for some time until I feel so I'm going to leave mind training until I feel it's now good enough for me to stop training, and then I'll come back later after it's done training. And basically that's how you train or you create AI models from scratch. I said for it to be accurate, you need to train it with so much data, good data, quality data, and now that's when this AI becomes accurate. Depending the size, the teams, the features that you are going to add, the security, all those kind of things. Now that when it comes bigger and bigger platform to work on. Anyway, that's it, guys, for today. I've enjoyed doing this. Thank you. See you in the next live session.